years. And it's obvious that after 3 years of running such a machine needs also a break. And not only the machine itself, but all the other machines at CERN, which are the pre-injectors to the LHC. So this is why we are still in the shutdown at the moment. And the shutdown was supposed to take 2 years. Within 1 day we are on schedule, so that's fantastic. We are now 3/4 through the shutdown, yeah, roughly 3/4. It's fantastic. But why did we need 2 years? Because we had to open the whole machine roughly every 20 meters over the 27 kilometers, which in order to do something, in particular to reinforce the interconnects between the magnets, and this is obvious that this takes a long time. We are restarting already the injectors, that means the smaller accelerators have already seen the first beam again. So the small experiments which are situated at these accelerators, they will get beam and therefore physics soon. The LHC is supposed to restart in January with seeing its first particles. Now physics, I hope, can restart around Easter or so, and I say Easter because I don't know when Easter is next year. It's around Easter next year that we hopefully get the first data. And then we assume roughly 3 years running period again for the LHC before it gets its other next big shutdown. And altogether, we foresee at the moment a 20 years additional program at the LHC. So if you take it time-wise, we have taken 3 out of, let's say, 25 years, so that's a 10% time-wise running. But if you look at the amount of collisions which we produce, we have only 1% of collisions up to now collected, so we want to get a factor 100 more until 2035. Because there's a huge amount of physics to be done. Discovering the Higgs boson is easy. That's at least what I told them once I have discovered it. The work starts now, and I think the work on the Higgs boson and what else is beyond it, all the fascinating physics which we are looking forward to, I think I leave to the particle physicist. Fabiola.
Thank you. So following up on what the DG said, clearly the discovery of the Higgs boson was an arrival point in the sense that it awarded the work to more than 20 years competent and dedicated work of the international community, but at the same time is a starting point. So with the higher energy at the LHC starting on Easter 2015, almost a factor of 2 larger, less than a factor of 2 larger than what we have today, many opportunities open. Actually, we have several certitudes, I will say, that gives us hope that we can really have a very exciting physics program. The first certitude is the Higgs boson itself. It's a new particle. And at the moment, we don't know it as well as we know the other elementary particles like the W and the Z boson, the top quark. And as it happens with a new friend, you want to know him or her. I don't know if you should say him or her for the Higgs boson, perhaps it. You want to know him or her better. And so we are going to measure it in all details, to do a complete scanning, complete identikit of this particle, not only because it's our duty to know it better, it's such a special particle, so different from all other particles we have discovered so far, but also because it's a door to new physics, because new physics, which is needed to address many open questions about matter and the universe, may well affect the way the Higgs boson interacts with the other particles. So this is one of our first goals. And the other goals are the other goals for which the LHC has been built, conceived and built, not only to discover the Higgs boson or better to understand the origin of the particle masses, but also to address many open questions that are still there, big question marks, big mysteries, like why the universe is made mainly of matter with very little antimatter. What is the particle that constitutes the dark matter? Why is the Higgs boson itself so light? And so we know that these questions are there, and we know that we need new physics to address them. The problem is, where is this new physics? Is this at the energy scale that the LHC will explore, starting in 2015? Or is the higher energy scale, which will call for future machines? Anyway, we have the duty and the right and the excitement to use the LHC, which is the most powerful accelerator we have in our hands today, in the best possible way, and exploring its ultimate performance. And this will take time, will take 20 years, because of course it requires a lot of data. There are some phenomena, like the deviations of the new physics will produce to the interaction of the Higgs boson with other particles, that require a lot of data because they are tiny. So I think I will stop here, not to abuse of the time.
Thank you very much.